Recap this again. Types of symmetry are line symmetry and rotational symmetry. Line symmetry means you can fold a figure in half and it will match it perfectly. It also means you can reflect over that line of symmetry and it will still map up onto itself. Because of that, line symmetry is also known as reflectional symmetry, and lines of symmetry can also be called lines of reflection. The other type of symmetry is rotational symmetry. This occurs when a figure can be rotated less than 360 degrees and it will map onto itself. The order is how many times that figure can be rotated, and it will still map up onto itself. There is really no order 1, since any figure without rotational symmetry would have an order of 1 anyway. Okay? So order is always 2 or more. So what we're going to do is we're going to be given different figures, and we have to determine if they have line symmetry, rotational symmetry, or both. If they have line symmetry, we're going to draw in the lines of symmetry and state how many they have. If it has rotational symmetry, we just have to give the order and the angle of rotation. So look at this first figure, F. Are there any lines of symmetry? Is there any way we can cut F in half so it matches up perfectly? No. None. No line symmetry. What about rotating it? Is there any way we can turn, you can kind of turn it on your paper, to turn F to get it to look exactly like F without doing a full circle? No. So it does not have any rotational symmetry. Doesn't have any symmetry. What about this butterfly? Does the butterfly have any symmetry? Yes. Yeah, where can we draw our line? Right down the middle. Have to cut this poor butterfly in half. This means if this butterfly was on a coordinate plane and we had this point right on the tip of the wing, if we counted the distance from here to the line of symmetry, it's the same distance from this exact point on the opposite side from the line of symmetry. So if we counted and then counted again, those points would match up exactly. So if we were to flip the butterfly over that line, you get the same exact image again. Nothing would change about it. Okay? So you have one line of symmetry. Can't draw any other ones in. I'm going to abbreviate. Does it have any rotational symmetry? Can we rotate this without doing a full circle? No. So there's none. No rotational. What about this triangle? What type of triangle do we have here?
We have a triangle.
Very good. Isosceles. How do we know it's isosceles? Very good. If these two angles are the same, then those two sides are the same, so that makes it isosceles. So how many lines of symmetry does this guy have? 1. Yeah. If it was equilateral, it would have more than 1, but because only these two sides are the same, that means there's only going to be 1. It's right down the middle. So you have 1 line of symmetry. Is there any rotational symmetry? One line of symmetry. And then no rotational. No way we can turn it so this is to map up on itself. Questions so far? Now you don't see a pattern. Like if there's no line, might be noticing that there's no rotational. If there's one line, you might be noticing that there's still no rotational. But what about this star shape? Yeah, it has lines of symmetry. It has 4, but let's see if it has any more than 4. It has 8. So if we go right down the middle here, that works. Where else do we draw one? Yeah, we cut it in half here. For all these vertices. It's in half there. There's 12. There's a cross here. I always mess that one up. ones can we draw in? Is that all, or are there more? Yeah, where can we draw the other ones?
In the middle.
Well, what do you mean by in the middle? Like,
This is one more.
yeah, in between, where these kind of inside. These inside points are. There we go. How many lines of symmetry did we draw? Yeah, very good. Some of you might not, it's a lot of lines, you might not be able to keep count. So what you can do, you can just do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Count all the ends of the line and cut it in half. Because like this end of the line matches up with that end of the line, so we can't count that line twice. So if you just count all of them and divide by 2, that's how many lines of symmetry you have. So we have 8 lines of symmetry. Does this guy have rotational symmetry?
Yes.
Yeah. Just to figure out how many times we can rotate it so that it maps up onto itself. Let's take a look at this point right here. If we rotate it to exactly here, there's 1 rotation, it will map up. If we rotate it again to here, it will map up. There's 2. There's 3. There's 4. 5. 6. And one more time would be 8. So when this does have rotational symmetry, the order is 8. It's how many times you can rotate it so the figure maps up to itself. We then have to find out the angle of rotation. Well, we started here and did a total of 360 degrees. So if we divide that by the order, or how many times we rotated it, that gives us our angle of rotation. So what's 360 divided by 8? 45. So that is the angle of rotation. This also means any multiple of 45 under 360 is also kind of an angle of rotation, meaning you can rotate this 90 degrees, and that still counts as an angle of rotation. You can rotate it 135 degrees, and it still counts as an angle of rotation. You rotate it 180, that counts. You might be asked that question on your quiz, or on a test, or on practice. It might say, like, which angle is not an angle of rotation? So you'd have to know, well, the main angle of rotation is 45. Which one of those is not a multiple of 45? And that kind of tells you what your answer is. So keep that in mind as well.
All right, let's do a couple more examples here. So you guys start getting the hang of it, see some patterns emerge. All right, we got this one right here. What kind of shape is that? Pentagon. You're right, it is pentagon. So does a pentagon have lines of symmetry? 1. I guarantee there's at least 1 in there. So which one is that? Right down the middle. Seems like a good one to go with. All right, there's 1. I agree. Anywhere else? Yeah. Where's another one? Diagonal? So there's another vertex. All right there. I like that one.
What?
Yeah. Yeah. What do you want? If I fold it in half that way, it's the same shape. As you rotate it that way, it'd be the same exact shape. Go from this vertex, cross. This vertex, across. And the last one, cross. So all those vertices. Those are lines of symmetry. You can fold those all in half. They're cut in half. All right. So, how many lines of symmetry are there? I'm going to use purple. I'll use blue. All right. So, how many lines of symmetry are there? 5? Well, let's see. Count we're at. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Half of 10 is 5. You're correct. Oh, what are the orders going to be? Here's a nice little trick. I can do it pretty well with a smart board. Because some of you guys have a hard time visualizing this. This is part of a unit where visualization helps out a lot. So we're right here. I want to see how you guys rotate this. Watch with the smart board what we can do. You guys will have to turn your paper. Right here. So how many times can I rotate this shape around itself? Well, let's see. There's one time. It's back to its same self. 2 times. 3 times. 4 times. 5 times. 4 goes all the way around. So the order is also 5. Well, since I can rotate, it has rotational. How much do we rotate each time? What's the angle of rotation? I don't know. Well, how far do we travel all the way around? 360. What am I going to divide that by? 5. What's 360 divided by 5? 72. So I rotate that 72 degrees. Sam, question?
Will the lines of symmetry like always be the same number as the...
Man, that's a great question, won't it? So far, so good, right? Let's see if that holds true. All right, let's talk about the flash over here. Lightning bolt. Well, a lightning bolt, this lightning bolt right here, have a line of symmetry. Can I cut this in half somehow and flip it on itself and it's the same thing? No, right? Okay, that's a no with that one. I agree. There's none with that, exclamation point. What about rotating it? What if I rotate this lightning bolt? Could it be the same lightning bolt rotated around? Well, let's find out. I like tracing these things. That's pretty good. Rotate it. Lightning bolt, lightning bolt, lightning bolt. Cool logo. Nope. Nope. Oh, can't do it. So it has none as well. Huh. So it doesn't have line symmetry. It's not going to have rotational symmetry. Pattern, Sam. Pop it up. Uh-oh. Valentine's Day coming up. Buy your loved ones, family members, candy. Teachers, we'll accept candy on Valentine's Day. You can guys bring us candy. Yeah, chocolate hearts. I'm more of a peanut butter guy, but whatever you guys want to do. Does a heart have a line of symmetry?
Yes. Yep.
Where?
Down the middle.
Right down the middle.
Make it zigzag so it's really hard.
Broken heart. So how many lines of symmetry does it have? It's got one. So line of sim. 1. What about rotational? Can I rotate this heart around? All right, we'll find out. I'll draw on my heart. That's pretty good there, can I? Just a fantastic artist, Drew. Rotate, rotate, rotate. Oh, heart is not going to map onto itself. So I got a none here. Last guy. What shape is this?
Stop sign.
You shapeologists. Stop sign. No, not a stop sign. Close.
I did do a stop sign.
Ooh, there's a stop sign right there.
Wait.
Looks totally different. It is a hexagon. It's a hexagon. Do you think this hexagon's going to have a line of symmetry? Yeah, where can I cut it at? Right down the middle. I'm talking vertically? Okay, let's talk vertically here. Let's go vertical. Shop it. Right there. There it is. Horizontal too. All right. Right there.
It's a window.
It's a window. Yes, it's a window. Diagonal right here. Okay. So right here. All right, I'm off a little bit somewhere, but you know what? You get the gist of it. All right. Oh, this other diagonal too. Good. Done. Done, right? What? There's 4? The vertices. I can X those up. This guy right here. Oh, that's good. I don't think I can do any more than that. So I hear a 6. All right. Let's see if we got that going on. Where am I? What color am I at now? I'm in red. I'm in black right now. All right. So we have lines of symmetry for sure. How many? I heard 6. Who said 6? You said 6. We'll find out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Half of 12 is 6. Huh, what kind of shape is that again? Huh, okay. What was this one? Huh.
Oh, good.
All right, well, let's see if there's any other things going on with this one. So the order. How many times can it rotate on itself? What? 6? No, there's no way that's right. I don't feel good about that. I'm going to trace it out and figure it out myself. One, 2, 3, 4, 5, 6, 7,
No,
8.
well,
Okay, back to 6. It is 6. Huh. So we know it rotates around. What is going to be its angle of rotation? Let's see. 360 says we go a circle. The order is 6. So I am moving 60 degrees. There we go. Questions with this? Okay. Ready, steady, decide.
As we look over the back, we want to figure out which of the following transformations would map this rectangle onto itself. And select all at apply. So that's indicating to you that there might be more than one way we can do this. Okay? Really nice because all your options are written out for you. So you just have to go down your list to decide which ones work, which ones don't. If they work, you circle them. If they don't work out, scratch them off. Okay? So what you can do to save yourself some time is we're going to do all these transformations, but we only have to do it on one point. Okay? If we reflect over the y-axis, and let's say we use this point, and it maps up with one of these other points, then we're good. Okay? If it doesn't map up with one of the other points, then we have to stop. Then we know, hey, it's not going to work. If it doesn't work for one, it's not going to work for any of them. Okay? So let's just take a look at A. Reflection over the y-axis. So all we have to do is just pick one point and reflect over that line. Which point do we want to use? Negative 4, 3, 4, 3, 4, negative 3, 4, 3. Okay. So when we reflect 4, 3 over the y-axis, again, you just count. How far is this one away from the y-axis? 4. Okay? So we count 4, then we go 1, 2, 3, 4. Did that map up with another point?
Yes.
Yeah. We know. We can test the other ones. Okay? We can reflect a point that's underneath the original red point. If we reflect it, it goes 1, 2, 3, 4. 1, 2, 3, 4. It maps up with that one. Same thing, these two are going to map up with each other because they're both 1, 2, 3, 4. 4 away. We count 1, 2, 3, 4. 1, 2, 3, 4. When we reflect it, it stays right where it's at. Same rectangle in the same spot. Okay? So it maps it onto itself. Well, let's try B. Reflection over the line y equals x. So let's go ahead and draw on that line. Remember, when it's y equals x, you start at the origin, and you just kind of go right down the middle, up 1 over 1. And down 1 over 1. You make that diagonal line right through the middle. And connect. Again, when we're reflecting over this line, when it's a diagonal line, again, pick any point. Which point do we want to deal with? 4, 3? Okay. So remember, when you're reflecting over the line y equals x, you count up or down till that point touches that line. So how far do we go up? 1. So when you go up, you're either going to go to the left or the right. Which direction do we want to go? So it's across. It's on the other side of that line. And you're going to go left that same direction. Does that point map up with any of the other points? No. So is this going to map onto itself? No. Done. Okay? It has to map up with one of the other ones. If it doesn't, it's not going to map up. It's just not. And the rectangle will end up looking, I think, something like this after you do that full. It looks something like that. And it's just not going to end up mapping. So you can just stop when that happens. Okay, let's try the next one. A rotation of 90 degrees about the origin. So again, pick one of those points. It doesn't matter. If you want to keep using 4, 3. Doesn't matter. You can pick whatever one you want to use. When we rotate something 90 degrees, what do we do with the point? What do you do with it? Flip it. Good. So it becomes 3, 4, and then what do we change? Yeah, very good. Change the sign of the first. So that becomes negative 3, 4. So let's plot it. Does that map up with any of the other vertices? No. So is it going to map up onto itself? No. Awesome. Then you go down your list. Shiny. Reflect over the x-axis. Pick any point. Which point do we want to use? Doesn't matter. It has to be on the vertices. One of the vertices.
I'm up -4, 3.
Perfect. -4, 3. Let's reflect it over the x-axis. So again, you just count 1, 2, 3. 1, 2, 3. Did that map up with another vertice? Yeah. So is that going to map up onto itself? Yeah. That one's going to work. Because it works for one point, it's going to work for all of them. Okay, let's try E. We're going to rotate this 180 degrees about the origin. So again, pick any point. Okay, what point do you want to use? 4, 3? Okay. So we rotate this 180 degrees. Do we flip the pointer at all? No. Stays the same. What happens to the sign? They just switch. Alright, so let's plot -4. -3. Or sorry. Yep. Technically this one. Does that map up onto one of the points? Yeah. So is it going to map up onto itself?
Yep.
Yep. That one works. And then finally, we're going to do this next transformation. This is supposed to be y equals -x. So I'll graph that line. It's the same as y equals x, it's just going in the other direction because it's negative slope. So it'll look like this. Okay. Same thing, Riley. Pick a point. Any vertice.
Can I pick -1, 1?
Vertice.
Oh.
Has to be a vertice.
-4, -3.
-4, -3. So again, when we're reflecting over a slanted line, you just count till you touch the line. 1, 2, 3, 4, 5, 6, and 1. Up 7. Do we want to go right 7 or left 7? We want to go on the other side of that line. So we're going to go right 7. Did it map up with any of those points? Nope. So it's going to map up onto itself? Nope. Just giving you a hint. You're probably going to have one like this on a quiz or a test that's coming up maybe on Tuesday. The test is scheduled for next Thursday. You might see one very, very similar to this. So this question is kind of important. is over